mean life of its furnaces is more than 18 years. So we need to write the null, the alternative, and then we need to determine if this is going to be a left tail, right tail, or two tail test, which is the last thing we talked about yesterday. All right, so is the claim the null or the alternative? It is the alternative, and it's a claim about the mean. So make sure you use the right variable, or mu, on that one. What's wrong? Is the computer broken again? Is that... Let's grab another one. Oh. Okay. The mean is greater than 18. So what's the null hypothesis? Less than or equal to 18. Okay, so based on that then, can you tell me if this is going to be a left tail, a right tail, or a two tail test?
Right tail.
It's going to be a right tail. And which part do you look at to determine that it's going to be a right tail? The alternative is going to tell you it's greater than, so it's going to be looking to the right. All right, any questions on that? A little recap from yesterday. Okay, so last thing that we're going to talk about, that's the same problem, there we go, today is when we go to section 7.2, we are going to be finally making decisions, okay? So we're going to be making decisions based on p-values that we'll find on our z-score chart, so probability values, and alphas, which yesterday we talked about what alpha was. Alpha is a level of significance that's predetermined. Depending on how p and alpha are related, we will either reject the null hypothesis or not reject the null hypothesis. The decision that is being made is always about the null hypothesis. Okay, now your claim could be either one. We know that. Yes?
Can you repeat like the significance of alpha?
Alpha is the level of significance that's predetermined for the problem.
Oh.
Okay, so that'll be something that's given to you on those. Okay, but the decision that's being made is we will either reject the null or not reject the null, because that's what we said yesterday is something that we are always assuming to be true. Okay, so the numbers and the math, we'll get to that part tomorrow. What we want to look at is this claim decision chart at the bottom. I would put like a big star by this, because when you do hypothesis testing, you're going to refer back to this set of information pretty much every single time. Our math is going to tell us either we reject or we don't reject the null. And then what's underneath these little boxes here is kind of like your summary statement on what that means for our hypothesis testing. Let me see if I can get the right thing. There we go. Okay, so let's say our claim is the null hypothesis and we choose to reject it. Your summary statement would be that there is enough evidence to reject the claim. Write this down word for word. There is enough evidence to reject the claim. If your claim is the null and you do not reject, we say there is not enough evidence to reject the claim. So we always are going to refer back to the evidence, because what we're making decisions on are statistics, not the population. So we talked about there's always that room for error. Yesterday we talked about type 1 and type 2 errors. So the evidence is telling us that we either reject it. Rejecting something says we're showing that it's false based on the statistics we have, or not rejecting it, which isn't saying we're proving that it's true. It's just saying we don't have enough information to say that it's false. Okay. The other alternative is that your claim is the alternative hypothesis. Again, our decision is always based on the null, though. Okay, so we either reject the null or we do not reject the null. If your claim is the alternative, the wording changes a little bit. If we reject, we say there is enough evidence, but this time we say we are supporting the claim. Okay, so when we reject the null, we're saying we can support the alternative. And if we do not reject, we say there is not enough evidence to reject the claim or support the claim. So notice we use the word reject on the left side. We use the word support on the right side. If we reject, that means there is enough evidence. Normally, we think of rejecting something as a bad thing. In statistics and hypothesis testing, it's a good thing. If you are able to reject the null, that means you have enough evidence to make a decision. If you cannot reject the null, you don't have enough evidence to do what you want to do, either reject it or support it. Okay. Yes.
So when you say like reject, that
Mhm.
means like it doesn't work, or like it doesn't occur, or like it's not right, is that correct?
Yes, we're saying that based on the statistics we have, when we reject the null, we're saying that the null is essentially false
Wrong.
based on the statistics we have. Yes. Okay, with a room for error, always room for error. All right, so I'm gonna flip ahead. I think we're gonna skip the next, yeah, we're going to use this one. Okay, interpreting a decision. It says, you perform a hypothesis test for the following claims. How would you interpret your decision if you reject the null or you do not reject the null? And we're giving an example of each here if our claim is one or the other. Okay, so let's start with first one. It says, the null hypothesis is a claim, and the claim is that a school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. All right, so we need to make a decision about what it's going to look like if the math that we eventually do will tell us to reject or not reject, how we would kind of summarize and what that would mean for this situation. If the math that we do tells us to reject, our wording would be, there is enough evidence, okay, to reject the school's claim. And you could even be a little more wordy with that if you want to. Claim that 61% of its students are involved in at least one extracurricular activity. If you do not reject, we say there is not enough evidence to reject the school's claim. Doesn't mean it's true. It just means our statistics don't tell us enough to say that it's false. The second one is an example of what you would do if your alternative hypothesis is the claim. So in this problem, it says a car dealership announces that the mean time for an oil change is less than 15 minutes. Let's say we reject, and remember we are rejecting the null. Okay, so you're rejecting the opposite of this when you make a decision in this case. All right, so we're rejecting the opposite, which would be instead of less than, greater than or equal to. So if we're saying it's not greater than or equal to, we have enough evidence to support this opposite statement that's being made. So we say there is enough evidence to support the dealership's claim. Okay. And then if we choose to not reject, again, the null, the opposite of this, we say there is not enough evidence to support the claim that the mean time for an oil change is less than 15 minutes. Okay, so if we reject, there is enough evidence in both cases. If we don't reject, there isn't enough evidence. If the claim is the null, we use the word reject. If the claim is the alternative, we use the word support instead. very detail oriented here, how we're going to summarize our findings. So if you were trying to prove that something is true, would you make your claim the alternative or the null hypothesis? You would make it the alternative, right? Because the alternative, the decision that we're making, if we make my claim the alternative, would support a specific statement. And if you're trying to show that something isn't true, if you're trying to prove something false, what would you make your claim? The null hypothesis. That's what the next slide says, pretty much. Okay? Depending on what you want to do, that's what you want to align your claim with. If you want to support something, your claim should be the alternative. If you want to reject something, prove it false, your claim should be the null. Okay? All right. So I'm going to flip ahead 2 slides where it says the you try. We're going to do these together. You represent a chemical company that is being sued for paint damage to automobiles. You want to support the claim that the mean repair cost per automobile is less than $650. Okay, so you represent them. You don't want them to be sued. You want to prove that the mean repair cost is a low number. Okay, how would you write the null or alternative hypothesis, and how would you interpret a decision that rejects the null? All right, so if you want to support something, should your claim be the null or the alternative? Okay, so let's write them, and we'll just use mathematical statements here. We won't use our words. All right, so the claim should be the alternative. And what is the claim that you're trying to support?
Alternative is less than 650.
The mean is less than 650. Good. Okay, and then what's the complement of that? That would be my null hypothesis, that the mean is greater than or equal to 650. Okay, second part of the question is, how would you interpret a decision that rejects the null hypothesis? So if we reject the null, if our statistics say that the mean is greater than or equal to 650, we can reject that. What does that tell us? Do we have or not have enough evidence? That's the first thing we have to decide. Yes, so if you reject, remember that's a good thing, okay? There is enough evidence. And if my claim is the alternative hypothesis, do we reject or support? Support. The chemical companies claim. Okay, so if you're the researcher here that's representing the chemical company, you want to be able to reject the null hypothesis. That's what you want to happen at the end of your findings, because then you can support the claim that's being made by the automobile company. Yes?
Why is there enough evidence to support the claim?
When you reject something, your statistics are showing that there is enough evidence to make a decision on the matter, essentially. Yeah, we don't have any of the math yet. This is just kind of a procedure that we're going to be using. We'll add the math later. Okay, but rejecting is a good thing. Rejecting is having enough evidence to make that decision. Okay, and because we're always making that decision on the null, if I reject this guy, if I say that the null is false, if I say that this is false, that's enough to say that this is probably true based on my statistics. Okay, because we're always either rejecting or not rejecting this, no matter what the claim is.
Okay.
Okay, so if I say this is false, I'm rejecting it, that means this is probably true. So we have enough evidence to support the claim that's being made.
Okay.
Okay. Yes.
Since it says support the claim, is that how you know that it's the alternative hypothesis?
Yes.
Okay.
So let's look at the next one. You are on a research team that is investigating the mean temperature of adult humans. The commonly accepted claim is that the mean temperature is about 98.6 degrees Fahrenheit. You want to show that this claim is false. How would you write the null and alternative hypothesis, and how would you interpret a decision that rejects the null? All right, so I want to show that something is false. I don't want to support it. So my claim should be what? The claim should be the null. And the claim that's being made is that the mean, again, temperature is about, so equals 98.6. And the alternative would be that the mean is not 98.6. Okay. Again, how would we interpret a decision if our math that we will eventually do rejects the null? Yes.
Sufficient evidence to reject, you know.
Yep. So again, rejecting is a good thing. We say there is enough evidence in our math that we'll do to reject the claim about temperatures. Okay, and this time we use the word reject because the claim is the null hypothesis, and that's what we're making the decision on. So if my math tells me reject the null, that's my claim. We're rejecting the claim. We're saying the claim is false. Yes?
Why did you say, for the alternative that the mean doesn't equal 98.6 instead of it is less than?
So it depends what my null was here. If this was like greater than or equal to, then I would use less than here. Or if it was less than, I would use greater than. If it's equal to, which this one said the mean temperature is about 98.6. It didn't give me any statement about less than, greater than. So it's equal to, not equal to. This is the one that will eventually give you the right tail test. It doesn't always have to be greater than, less than. All right. Questions on any of these? Just very specific with the wording. Okay. The last slide isn't anything we're really going to get into today. You guys are going to see this again in the next lesson, actually in the lesson after that too. This is the procedure that we're going to be using to put all of these little pieces that we've talked about in this section together to actually do a hypothesis test. So we talked a lot about the hypotheses at the top. Level of significance we mentioned. Again, that's probably going to be given to you in most problems. We're going to figure out if it's a left tail, right tail, or two-tail test. We know how to do that. We're going to calculate the test statistic, which is either a Z or a T. We already know how to do that from previous sections. And then that's going to give us a p-value off of our chart. Once we have the p-value, we'll compare it to the alpha value, and then that'll tell us to reject or not reject. And then based on that, we can make a summary like we just practiced. So all of these little things that are kind of seemingly floating on their own are going to come together starting tomorrow for this kind of larger, big idea that we're getting to, okay? That is it for 7-1 then. That's all I got for you. So remember, you have 3 parts to your 7-1 homework. All 3 of those are due by tomorrow night. You guys have a little over 20 minutes now. You can get some work done if you want. Let me know if you have questions, and then tomorrow we'll start 7-2. Yes?
Can you go back to the try slide?
Go back to the you try slide. This one?
Yeah.
There you go. I'll leave it up there for you.
So it's tomorrow worth it.
Tomorrow is not a work day. We're going to start 7-2.
Yes.
Tomorrow, I know. I knew you'd be excited.